Okay, so let's look at these two questions here, 6 and 7. The first one is telling shade B complement intersect of A intersection of C in the Venn diagram in the space. This is space here. So how do we shade this notation there? So here's what we can do to help us, all right? Step 1 is anytime you see a complement, they mean not part of that. So when we say B complement, we mean not in B. Are we there? Okay? So our first step which we are going to do is that we are going to first shade A intersect C. Now, this is another intersection, not a union. This is where things get messy if you don't pay particular attention. So where is A intersect C? So you discover that A intersect C is actually everything here, right? That is A intersect C is everything there. But they are saying they don't want anything to do with B. They don't want anything to do with what? B. Which one has got anything to do with B? You should be able to know that this part here, it's part of B, right? This part here, it's just that part alone there, it's part of B. Why? Because it is the intersection of all the three sets. So that part here should not be there as we shade. They don't want anything to do with B. So that means that part must be removed. We only remain with this part. That's all. Are we together? That means anything to do with B is completely out. Because set B is that whole circle there. And we don't want anything to do with B. That is to do with the intersection. So remove that part intersection because this part is this part, that part, and that B. But we don't want it. We only want things to do with A and C. Kwasila. In short, this, in other words, this is just A intersection C only. This. Alright? That. Next is this one here. Given that matrix A is this and B is that one, find A transpose and then find AB as a single matrix. So, A transpose, it means you just change the order or you swap. Alright, so this is a row, it becomes a column. This is another row, it becomes a column. That's all. You are done. You see how easy it is, right? So how do we find AB as a single matrix? Or what they're telling us to do is to multiply them. And you can only multiply them if and only if the number of elements in the row of one element is equal to the number of elements in the column of the other matrix. So here we've got 3 elements in the rows of matrix A, and you've got 3 elements in the column. All right, you can say there are 3 as well in the matrix B. That means we can multiply them. If that's not met, you can't multiply them. Let's say here we've got 3, but here we've got 2. Let's say we don't have this row, but there are only 2. Then we cannot multiply. All right, that's how it works. So here's what we do. We multiply that, it's row by column always. So if we start with this row must multiply every column until you get done with it. Are we together? So let's go. So 3 times 3. So 3 times 1, then 2 times 3, then 1 times 0. Those you add them because it is a single row and single column. You add them. So we say 3 multiplied by 1 plus 2 multiplied by 3 plus 1 multiplied by 0. So this row has multiplied the whole column. So you add those products out together. Then you leave a space. This column, this row should again multiply that column. So again we start 3 multiplied by 2. You're adding them. 2 multiplied by 2 plus 0 multiplied by 1. Oh, sorry. 1 times 1. Again we leave a space. This should multiply that column again. So we're saying 3 multiplied by 3 then we have 2 by 1, then we have 1 by 0. So we are done. We come to the next column. So in the next row, should again multiply that column, it's just like this. So we will just be repeating the same numbers that are at the end. The only thing that will be changing now is the numbers at the beginning. The numbers at the end are the same, all right, because we're dealing with the same columns but a different row now. So it will be 4, 1, it will be 3, and here 3, it will be 0 and 0, it will be 4 and 2, it will be 3 and 2, it will be 0 and 1, it will be 4 and 3. The numbers at the end are maintaining, then 3 and 1, then the next one it will be 0 and 0, 0 and 0. So like this, then you close and you do that. Are together? So now we can now begin multiplying. So 3 and 3 is what? 3. So 3 and 1 is 3 plus 6 plus 0. I'll come down here is 4 plus 9 plus 0. 6 plus 4. Don't ask me on how I'm multiplying by now. Come on. You can't tell me that you can't fail to multiply these numbers. Here we get 8 plus 6 plus 0. We get 9 plus 2 plus 0. 12 plus 3 plus 0. This will give us 9, and we get 11 here. What do we get here? The 11. What do we get here? 13. We get 14. We get 15. This becomes your AB. Then you come and here and write it. Okay, final answers. AT, you put them there. 3, 2, 1, 4, 3, 0. AB, okay, you write 9, 11, again 11, 13, 14, 15. And we get 1 and 2 marks. Total 3 free marks. These are free marks for free. Okay,